It's pretty wild to think that over 160 years ago, Charles Darwin published his world changing theory of evolution. And not too long after, Albert Einstein published his theory of relativity. But here's the thing, while pretty much every new discovery has made Einstein's ideas stronger, a growing number of scientists are arguing that the exact opposite is true for Darwin's. Today, we're going to dig into why three really distinguished scientists, we're talking a biochemist, a mathematician, and a geophysicist, are all convinced that modern science has actually made the case for Darwinian evolution weaker, not stronger. When you ask them point blank if Darwin's theory has held up over time, their answer is, well, it's a hard no. And it's not just one of them, it's all of them. They argue that one discovery after another in all these different areas of biology haven't supported Darwin's big ideas. Instead, they've actually started to unravel them. And we're not talking about some minor little disagreement here. This is a fundamental challenge to the whole story of life that most of us learned in school. So what's at the heart of their argument? Well, it really comes down to this stark contrast in how science has treated these two giants, Darwin and Einstein. Let's take a look. This slide really just lays it all out. For Einstein, the new evidence just keeps rolling in and proving him right. I mean, things like GPS satellites having to account for time moving at different speeds, just like he predicted. But these scientists say that for Darwin, it's been the opposite story. Big discoveries in fields like paleontology and genetics have created these massive problems for his theory. So let's unpack the first big one. Okay, so the first major hurdle comes right out of the ground beneath our feet, the fossil record. See, Darwin expected that we'd find this long, slow, gradual history of life unfolding. But instead, what paleontologists keep finding is this pattern of sudden, explosive appearances of new life forms. The most famous example by far is something called the Cambrian explosion. The Cambrian explosion was just bam. It happened so fast, geologically speaking, that Darwin himself knew it was a huge problem for his theory. In what's really a blink of an eye, dozens of brand new, super complex animal body plans just show up in the fossil record. They're fully formed, with absolutely no ancestors to be found in the older rocks below them. And you know what? It wasn't a one-time thing. This pattern of abrupt appearance happens over and over again, with the first insects, the first birds, the first mammals. And this right here just illustrates the disconnect perfectly. Darwin predicted this single, beautiful tree of life, with everything slowly branching off from one common trunk. But as geophysicist Stephen Meyer explains it, the fossil record looks a lot more like an orchard of life. You've got these major groups of organisms just popping into existence like separate trees, with no connecting branches down below. The crazy part is, the more we dig, the more explosive the Cambrian event looks, which only makes Darwin's original doubt even deeper. Now, the second major problem isn't buried in ancient rock. Nope, this one is coded inside every single one of your cells. This is the great enigma of biological information. Where in the world does the massive amount of digital code you need to build a new animal even come from? Back in Darwin's day, the cell was just a simple blob of jelly, a black box. But today, we know it runs on an incredibly sophisticated code. The discovery of DNA back in the 50s totally changed the game. It showed us that life, at its very core, is based on information. The four chemical bases that make up DNA, A, C, T, and G, they literally function like letters in a sentence, or maybe a better analogy, the zeros and ones in a piece of software. I love this analogy from Bill Gates, which Stephen Meyer points out. It's so powerful because it gets right to the heart of it. We all know intuitively that software doesn't just write itself. It needs a programmer. A code needs a coder. So when we find this ridiculously complex digital code at the very foundation of all life, it forces us to ask a pretty profound question. And this is really the key. The Darwinian mechanism, random mutation, and natural selection has to be able to generate all this new information from scratch. As Meyer points out, wiping out the dinosaurs might open up a new spot in the ecosystem, but that doesn't explain how the brand new genetic information needed to build a brand new type of animal to fill that spot just magically appears. Blind chemistry just doesn't write code. All right, the third problem takes us even deeper. We're going down to the molecular level now. This is the world that biochemist Michael Behe explores, and it's a world of such staggering complexity that Darwin couldn't have even dreamed of it. What Darwin thought was just simple protoplasm has turned out to be more like a microscopic, bustling city, just packed with tiny factories run by actual molecular machines. And I mean literal machines, things like propellers that spin, little trucks that carry cargo, turbines that generate energy, all built from molecules and working at a nanoscale.
And as you can imagine, this discovery creates a huge challenge for Darwin's idea of slow, gradual, step-by-step evolution.
To get his point across, Michael Behe came up with this term, irreducible complexity. Now, I know it sounds like a bit of a mouthful, but the idea behind it is actually super simple and intuitive. Behe's famous mousetrap analogy makes this crystal clear. Think about it. A simple mousetrap needs all of its parts to work. You need the wooden base, the spring, the hammer, the little catch. If you take away any one of those parts, you don't just get a mousetrap that works poorly, you get something that doesn't work at all. It's useless. Now, Darwin's theory requires that every little step along an evolutionary path has to give some kind of survival advantage. But for an irreducibly complex system, the halfway stages don't do anything. So what is there for natural selection to select? So, let's recap. We have big problems coming from the fossils, from the information in DNA, and from these tiny molecular machines. If the Darwinian engine of random mutation and natural selection just doesn't have the creative horsepower to explain all this, then what's the alternative? And this is the question that really shifts the conversation. It moves from just criticizing one theory to actually proposing another one. These scientists argue that the evidence doesn't just cause problems for Darwinism, it actively points towards a totally different kind of cause. You know, this quote, of all things, really gets at a basic rule of how we reason about the world. Some things we see, well, you just know they didn't happen by accident. A turtle on a fence post is an effect that just screams out for an explanation, for some kind of agent that put it there. The big question then is, does biological information do the same thing? Stephen Meyer leads out the logic here, and he's actually using Darwin's own scientific method. It goes like this. First, we see this incredibly powerful effect, the digital code in our DNA. Then, we look around for a cause that we know can produce that kind of effect. So, when it comes to information, whether it's in a book, or in a computer program, or a radio signal, what is the only cause we've ever seen that can produce it? An intelligence, a mind. And for these scientists, the conclusion is unavoidable. The digital code in our DNA isn't just a problem for some undirected random process. It's a positive, testable sign that an intelligent mind has been at work. At this point, you can see the debate starts to get bigger than just the data points. It becomes a really fundamental question about what science is even allowed to conclude. It's a clash between two profoundly different ways of looking at the world and all the evidence in it. Just look at these two conclusions. Richard Dawkins looks at the universe and sees proof of absolute purposelessness, and then Cardinal Ratzinger, who later became Pope Benedict, he looks at the exact same scientific data from microbiology and biochemistry and sees the hand of a creating intelligence more clearly than ever before. This really highlights that the debate isn't just about the facts. It's about the worldview, the lens you use to interpret those facts. So let's just pull it all together. We've seen the arguments from the fossil records, sudden bursts of creation, the digital code in DNA, and the tiny complex machines inside the cell. There's also a fourth line of reasoning, which mathematician John Lennox brings up. It's more philosophical. He argues that if our own minds are the product of a mindless, unguided process, then why should we trust our own ability to reason about anything at all? And all of this leaves us with a final, really big question. When scientists try to follow the evidence wherever it leads, can that path actually lead them beyond the strict borders of materialism? Or are we just watching a fundamental clash of worldviews, where one side's evidence is always going to be out of bounds for the other, meaning the debate can never really be settled by the data alone? It's a question that gets to the very heart of what science is and what it can be.